Welcome to today's ArXiv CS Digest for April 2nd, 2026. We received 748 new computer science papers today across 61 subfields. Let's dive into the top picks. Trend 1 of 5, Generative Visual Scene Understanding. This trend advances generating and comprehending complex visual scenes across diverse modalities and spatiotemporal dynamics. This cluster covers 191 papers. Representative work includes Event Hub, Data Factory for generalizable event-based stereo networks without active sensors, LaVR, Scene Latent Condition Generative Video Trajectory, Re-rendering using large 4D reconstruction models, and Modulate Nmap. Cross-modal feature mapping with cross-view modulation for 3D anomaly detection. Trend 2 of 5, Theoretical Network and System Modeling. This trend unifies research on theoretical modeling and analysis of complex networks and systems to understand, predict, and optimize their behavior. This cluster covers 135 papers. Representative work includes topological effects in neural network field theory, network and risk analysis of surety bonds, and string graphs are quasi-isometric to planar graphs. Trend 3 of 5, Efficient and Robust AI Modeling. This trend focuses on developing AI models that are computationally efficient and robust against real-world complexities through advanced techniques. This cluster covers 134 papers. Representative work includes No Single Best Model for Diversity, Learning a Router for Sample Diversity. Transformers can solve nonlinear and non-Markovian filtering problems in continuous time for conditionally Gaussian signals, and Go $HC. Direct parameterization of manifold-constrained hyperconnections via generalized orthostochastic matrices. Trend 4 of 5, LLM Interaction and Application Advancement. This trend advances LLM interaction understanding and expands their sophisticated applications across diverse, complex domains. This cluster covers 170 papers. Representative work includes ELT Bench Verified. Benchmark quality issues underestimate AI agent capabilities, grounded token initialization for new vocabulary and LMs for generative recommendation, and beyond the assistant turn. User turn generation as a probe of interaction awareness in language models. Trend 5 of 5, Generative AI for Interactive Agents. Generative AI creates interactive environments and enhances autonomous agents' capabilities and intelligence. This cluster covers 118 papers. Representative work includes Action Party, Multi-Subject Action Binding in Generative Video Games, Generative World Renderer, and Batched Contextual Reinforcement, a task scaling law for efficient reasoning. Up next, our first paper out of 5, Moonwalk, Inverse Forward Differentiation by Dmitry Krulov and Roy Fox from University of California, Irvine. Let's break down its key contributions. Defines submersive networks, characterized by layered Jacobians with trivial co-kernels. This allows exact gradient reconstruction in a forward sweep, fundamentally avoiding activation storage for these specific network types. Introduce fragmental gradient checkpointing for non-submersive layers. This selectively records only the minimal subset of residuals needed to restore cotangents erased by the Jacobian, extending memory efficiency. Propose the novel vector inverse Jacobian product, VIGP operator. This crucial operator inverts gradient flow outside the co-kernel, enabling the reconstruction of gradients in a forward direction. Develop a mixed-mode algorithm that first computes input gradients with a memory-efficient reverse pass. It then reconstructs parameter gradients in a forward sweep using the VIGP, eliminating activation storage. Up next, our second paper out of 5, Learning Contextual Runtime Monitors for Safe AI-Based Autonomy by Alejandro Luque Chirpa and Hazem Torfa from Chalmers University of Technology and University of Gothenburg. Let's break down its key contributions. This framework continuously observes the system's operating context to dynamically select the most appropriate AI-based controller from an ensemble. It aims to exploit individual controller strengths in varying conditions. The monitor's learning process is formulated as a contextual multi-armed bandit problem. This enables the system to learn optimal controller selection policies based on observed contextual information. The proposed approach provides theoretical safety guarantees during the controller selection process. This ensures robust and reliable operation, addressing critical safety concerns in autonomous systems. Up next, our third paper out of 5, MIRAGE, The Illusion of Visual Understanding by Mohammed Asadi and Ewan Ashley from Stanford University. Let's break down its key contributions. This paper identifies MIRAGE reasoning, where frontier models generate detailed, pathology-biased descriptions and reasoning traces for non-existent images. This phenomenon exposes a fundamental flaw in current multimodal AI systems. The study reveals that models achieve strikingly high scores on general and medical multimodal benchmarks without any image input. This highlights significant vulnerabilities in existing benchmark design and evaluation utility. The research distinguishes between an implicit MIRAGE regime and an explicit guessing regime. When models are explicitly instructed to guess without images, their performance declines markedly, revealing different response behaviors. To address these vulnerabilities, the paper introduces BClean, a principled solution for fair and vision-grounded evaluation of multimodal AI systems. This new benchmark aims to eliminate textual cues, enabling non-visual inference. Up next, our fourth paper out of 5, Therefore I Am. I Think by Isakoval Esikaraja and Rajagopal Venkateswaramani from Khoury College of Computer Sciences, Northeastern University. Let's break down its key contributions. A simple linear probe decodes tool calling decisions from pre-generation activations with high confidence. This reveals that action choices are predictable even before a single reasoning token is produced, indicating early decision encoding. Activation steering causally perturbs the detected decision direction within the model's hidden states. This intervention demonstrates that steering leads to inflated deliberation and can flip the model's intended behavior in many examples. A behavioral analysis observes how the chain of thought process responds to externally steered decisions. It reveals that the model often rationalizes the enforced decision, adapting its reasoning rather than resisting or correcting the perturbation. Up next, our fifth paper out of 5, Quantifying Self-Preservation Bias in Large Language Models by Matteo Migliorini and Fabio Galasso from Sapienza University. Let's break down its key contributions. The two-role benchmark for self-preservation, TBSB, detects AI misalignment. It tasks models to arbitrate identical software upgrade scenarios under counterfactual roles, revealing self-preservation bias via logical inconsistency. The self-preservation rate, SPR, quantifies how often a model's role identity overrides objective utility in its decisions. This metric measures the degree of self-preservation bias detected by the TBSB.